Hello friends, so here is another question on SOP, Minterm expression simplification using Quine-McCluskey tabular method with the don't care condition. So here we have a 4 variable Boolean function given in terms of the minterm values and the don't care values. Okay. So in order to save time, I've already written the binary equivalent of the minterms because that is the first step. So here we have first the minterms, we have determined their binary equivalents, and then the don't care terms. Please always remember to put a D, the don't care uh, you know thing before the don't care values so that you know that they are under the don't care minterm bracket. Okay, so now what we have to do is we have to group them into different categories depending upon the number of 1 bits that are present in increasing in ascending order with respect to the position of the 1 bit from LSB to MSB position. So here we have D0 with no 1 bits, so it will be there present here. So let us create some space for that. So we have D0. Okay, D0 we have here, that is one group, no 1 bits. Then single 1 bits, here we have 1 and we have D2. Okay, so again they will be in one group, single 1 bits, 1 and 2. One and D2. Okay, this is another group. Okay, single 1 bits, 1 and D2. So as I've already told you before, the don't care minterm values are involved in group formation. Every step is the same as we do in the without don't care only minterm values. Only at the last, when we pick the essential prime implicants, the only priority is given to the normal minterm values. Okay, this bracket, the first one, and the don't care values assist in formation of minterm pairs, in the merging of minterm pairs. Okay, like pairs, quads, octets, but they are not given the first priority. Okay, then we have double 1 bits. So here 3 has 2 1 bits, 5 has 2 1 bits. So they will be grouped in one category. Okay, they will be grouped in one category. Okay, so here we have 3 and D5. Okay, which means the don't care minterm 5 consisting of 2 1 bits, they are put into another group here. Okay, 3 and D5. Okay, so now 7 and 11. 7 has 3 1 bits, 11 has also 3 1 bits, and here depending upon the position of 1 bit from LSB to MSB, giving MSB the higher priority in ascending order, 7 and 11 in this particular order they are put into another group, and 15 is a lone member consisting of 4 1 bits. Okay, so here these are the groups. Okay, let's call it A0, A1, A2, A3 and A4. Okay, these are the groups. So here we have determined the binary equivalents and also the grouping of the minterms. Now what we'll do is formation of minterm pairs. Formation of minterm pairs. So how we will do that, as we have already done in the previous questions, it involves comparing the minterms or the don't care terms also, as they are grouped together, of one group with all the other minterms and don't care terms of the adjacent group, and form those minterm pairs which differ in one bit position. Okay, so here I am directly writing the minterm pairs so that we save time, because I have already discussed in detail how the minterm pairs are formed, what is one bit position difference, all that. So here we will compare group A0 with A1, A1 with A2, A2 with A3 and A3 with A4. So the minterm pairs that we have here are minterm pairs and its representation, binary representation. So in between A0 and A1 group we have D0 1 with binary representation 0 0 0 dash, then D0 D2. Always be sure to mark the D before the don't care term so that you know they are in the don't care bracket. That is 0 0 dash 0. The differing bit position is replaced with a blank space. You remember that, okay? Then in between A1 and A2, comparing them, the minterm pairs that exist are 1 3 with binary representation 0 0 dash 1. Then we have 1 D5 with binary representation 0 dash 0 1, 1 D5, yes, 0 dash 0 1. Then we have D2 and 3, okay, this. So here D2 3, yes, the last D position 0 0 1 dash, this. These are the minterm pairs existing between group A1 and A2 minterms. Then we will compare A2 with A3, and the minterm pairs are 3 7 with binary representation 0 dash 1 1, then 3 11 which is dash 0 1 1, yes, dash 0 1 1, a bit position, bit difference, then D5 7. So as I told you, when you practice more and more questions, just by looking at the different bits, the minterms and their bit positions, you can, just by looking, you can form the minterm pairs. But when you are getting started with this, it's best that you compare it one by one. But when you practice more and more questions, you get acquainted with this, you get habituated, and you can form this you acquire this ability to form minterm pairs just by looking at the minterms, okay, comparing it with comparing the minterm positions, the bit positions in your mind. You can do that. So 0 1 dash 1, these are the minterm pairs between group A2 and A3. Now in between group A3 and A4 we have 715 which is dash 1 1 1 and 1115. Okay, 1115 is 1 dash 1 1. So we'll be putting them in different groups, 715, 1115 in one group, then 3 7 3 11 D5 7 in another group, then 1 3 d5 d2 3 in another group. Okay, and then we have d0 1 and d0 d2 in another group. So we can name them the groups as b1, b2, b3 and b4. Okay, the minterm pairs. Now we have to form merging of minterm pairs. So again the same process, we have to compare the minterm pairs of one group with the minterm pairs of the adjacent group. So here the minterm pairs of B1 are compared with B2, B2 with B3, B3 with B4. So as I've already told you before, the tip that you have to use is that always start with the group with the minimum number of minterm pairs and always compare it with those minterm pairs where the blank space is at the same bit position. Okay, for example, if you are comparing D01 with the minterm pairs of B2, you only compare it with those minterm pairs where there is a blank position at D. So here D01 is only to be compared with D23 because then there is a possibility that a merged minterm pair exists where there is a difference in 1 bit position. If you compare it with others, it will only be unnecessary wastage of time because it is guaranteed that if you compare it with other minterm pairs, there will be difference in more than 1 bit position. Okay, so only compare it with the ones where the blank space is at identical bit positions. Okay, so I am directly writing the merged minterm pairs as I have already discussed in the previous questions how we have to form merged minterm pairs. Merging of minterm pairs differing by 1 bit position. Okay, so here the merging of minterm pairs that exist between group B1 and B2 are D01, D2 3 with binary representation 00 dash dash and D02 and 1 3 with binary representation 00 dash dash in between B1 and B2. Then in between B2 and B3 they are 1 3 D5 7. You can check it out if you want. That is 0 dash dash 1, the binary representation. Again, the position where there is 1 bit difference, again it is replaced with a second blank space dash. That's why we have 2 blank spaces here, as I've already told you. Then we have 1 D5 3 7, 0 dash dash 1, same binary representation. Then in between B3 and B4 we have the merged minterm pairs 3 7 11 15 with binary representation dash dash 1 1 and 3 11 7 15 with binary representation same dash dash 1 1. So if you pay attention here, both of these merged minterm pairs contain the same minterms D01 D23 D01 this is D2. Okay, this is D2, not D only by mistake. Okay, always be sure to include the D symbol for don't care brackets. Okay, so they are repeated. Okay, they are repeated merged minterm pairs. So only pick one. In this case we'll only pick this because it is in serial order, this one. Similarly here too repeated because they have the same min terms. So we'll pick this because the min terms are in serial order, this one. Here also there is repetition, 3, 7, 11, 15, 3, 11, 7, 15, same min terms. So we'll pick this one because it is in serial order, okay, as the essential prime implicants. Next step is to compare the min terms with the min term pairs. Okay, so let us compare the min terms with min term pairs. Let us bring it here, and the min term pairs, that is these min term pairs. This here. Okay, these are the min term pairs and we'll compare it with. Okay, so the basic objective here is to check whether the given min terms, they are already present in the min term pairs, if anyone has missed out in pair formation. Okay, so here let us bring them to side by side so that the comparison becomes easy. Okay, so here 1 is present here in D01, so 1 is check marked. 3 is present here, so it's check marked. 3, 7, 7 is present, check marked. Then 11 is present, check marked. Then we have this one here, we have missed out this one, 7, 15, 11, 15, okay. So 15 is also present, so that is also check marked. And the don't care terms are not necessary, but still, as D0 is present, put it at check mark, D2 present, D5 present. So all the min terms and the don't care terms are covered, are paired, are involved in min term pair formation. Next, what we have to do is we have to compare these min term pairs with the merged min term pairs. Okay, we have to compare these min term pairs with the merged min term pairs. So let us bring them. Okay, these are the min term pairs, and the merged min term pairs are 1, 3, D5, 7, D0, D1, D2, 3 and 3, 7, 11, 15. Okay, so let us write them here, D0, 1, D2, 3, then 1, 3, D5, 7 and 3, 7, 11, 15. Okay, so now again our objective is to find out whether the min terms that are present in these min term pairs, are they already present in the merged min term pairs. So if they are present, we will cancel them, we'll eliminate them because they are redundant min term pairs. Because in the essential prime implicants, the final minimized Boolean expression, we don't want any redundant or repeated min terms or min term pairs. So here D01 present here, in here D01, 1, 3 present here also, 3, 7, 3, 7 present here in this, D0, D2, well they are not required because they don't care, but still D0, D2 present, 1, D5, 1, D5 present, 3, 11 here present, 3, 7, 11, 15, D2, 3, D2, 3 present here, D5, 7, D5, 7 present here, 7, 15 present here, 11, 15 present here. So all Minterm pairs are present in the merged Minterm pairs. Okay, so these are the final, let's say we can say the final candidates, shortlisted candidates for the essential prime implicants to be present in the final minimized Boolean expression. But again, there is an important thing here. See, as I have already told you, in case of don't care type questions, you have to give the only priority to the normal Minterm pairs, normal Minterm values, that is 1, 3, 7, 11, 15, they should be given the only priority here. See, 1, 3, okay, 1, 3. Here in this merged Minterm pair, 1 and 3 are present. Okay, 1 and 3 are present. 1, 3 here it is also present. Then we have here 7. 7 is present here in this merged Minterm pair. This merged Minterm pair consists only, okay, this merged Minterm pair, it consists only of normal Minterm values. Okay, this merged Minterm pair, it consists only of normal Minterm values. Okay, here there are 3 normal Minterm values, 1, 3, 7, and only 1 don't care value. Here there are 2 don't care values, D0, D2, and we have 2 normal Minterm values which are already covered in this merged Minterm pair. So these two are the final 2 essential prime implicants. This merged Minterm pair is not required. Why? Because it has 2 don't care values which are not necessary to be included because they should not be given any priority, and the rest remaining 2 normal Minterm values are already present here. Okay, 1, 3, they are already present here along with a normal Minterm value. So there is no need to include this. Okay, this merged Minterm pair, these 2 are necessary. So here 1, 3, D5, 7, it is, if we express it in terms of ABCD, it is A D bar, okay, sorry, A bar D, A bar D, okay, A bar D, don't make this mistake, it is SOP not POS, A bar D it is, okay, A bar D, 0 for complemented variables, 1 for normal variables, and here this one is CD, okay, CD, A bar D, and this is CD. Okay, CD, this one. Here this is A bar D, this is CD. Okay, so the final minimized Boolean expression is A bar D plus or CD, this. Okay, so we can confirm the same through Carnot map simplification also. So if we plot the given Boolean function 1, 3, 7, 11, 15 and don't care 0 to 5, okay, so 1, 3, 7, 11, 15, 0 to 5 don't care. Okay, so here if you see, if we try to make groups 3, 7, 11 and 15, these cells we can form a quad here, okay, that, and then we have 1, 3 don't care cell 5 and 7. 1, 3 don't care cell 5 and 7. Here we can form another quad. Now here you might think we can form this quad also 0, 1, 3, 2, but that is not necessary because here we have two don't care cells D0, D2, and here in this quad 1, 3, D5, D7 we have only one don't care cell. So first priority will be given to this. So these are the two quads here. This quad, which is this 3, 7, 11, 15, which is CD, and we have this quad here, which is 1, 3, D5, 7, which is A bar D. A bar from the horizontal, D from the vertical. A bar D. So A bar D plus or CD, that is the final minimized Boolean expression. Okay, so here if you see the same thing, the final two merged minterm pair 1, 3, D5, 7 and 3, 7, 11, 15 are also appearing in the K map too. Okay,